Hey guys, welcome back. This is Mr. Marone here, just getting you ready to continue on with our triangle congruence discussion. So we've just finished up your quiz on side, 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 and side, angle, side, triangle congruence. So we're going to take a look at the other three shortcuts here really briefly. As you've seen so far, the shortcuts are very much a basis of what is stated in their naming. So we're going to take a look at that as we go through this. So the first one we're going to look at is the angle side angle congruence. And it's just a complete reverse of what we have when we talk about side angle side. So here, if we look closely, they're saying that if angle A is congruent to angle D, okay, our first angle here, then if we have a side included in between it, so the side is now sandwiched, in this case side AB is congruent to side DE, and then we have another angle, in this case angle B is congruent to angle E. If all three of those things are true, then we can say that triangle ABC is congruent to triangle DEF. Okay? And as they highlight down here, included means the side between the angles. Okay, this is really key, just like it was with side angle side. So let's take a quick look at a sample proof here. The left side has been filled in. We just have to fill it in the right-hand side. And they tell us that SQ is a bisector for two separate angles. It tells us that there's a bisector for RQT and for RST. So we can go ahead and write given in for our reason there. Okay? And when we say that SQ bisects RQT, okay, that means that we've got RQS, this angle right here, and it's going to be congruent to TQS, which is this angle right there. And that's the definition of an angle bisector. That's what it means to be an angle bisector. And the same thing's true for step 3. If this same segment QS bisects these two angles on the right-hand side, we have a definition of a bisector again. Definition of an angle bisector. Okay. Now, the last thing we need to say, as you see here, they said that QS is congruent to itself, which we know from much practice now is the reflexive property. Okay. Now, I've got a set of angles, I've got an included side, and I've got another set of angles, so we can say that these two triangles are congruent by angle, side, angle. The last one that we can use on any triangle is the angle-angle side congruence theorem. Now, I told you we could not use angle side side, but we can if we've got two angles and then a non-included side. Okay, so in this case, they're saying that angle A is going to be congruent to angle D. They said that angle B is going to be congruent to angle E. And then we have a side length, in this case BC being congruent to EF. Uh-oh, computer seems to be lagging a little bit. We'll see how long it takes to come back. There we go. Segment EF. Sorry about that, guys. And if all three of those are true, then we can say that triangle ABC is congruent to triangle DEF. Right? And the big key with this one is that we have a non-included side. Okay? The side does not have to be and cannot be between the angles for us to be able to use angle side angle, or angle angle side. Pardon my misspeaking. So we've got a sample proof here. I'm going to pause for a second and fill in the left-hand side. So while I do that, press pause on the video and see if you can fill in the left-hand side on your own. Alright, so now that that is all filled in, I'm going to go up and mark up my triangle here. And it tells me that I've got a set of congruent angles here, that I've got a set of congruent angles here, and that I've got a congruent segment here. Okay, parts 1 and 2 were both given to us, okay, and I ordered them this way so that I could address step 2 down here in step 3. So that's why I wrote them backwards to the way they were given. But the first two are given to us. The third step is exactly what we did before. It's the definition of an angle bisector, what it means to be a bisector. The definition of an angle bisector. Okay. Step 4 we know is when any segment or any angle is congruent to itself, we can use the reflexive property. So in this case, I use the reflexive property here. Okay. And then finally, we've got a pair of angles, pair of sides, which allows us to use angle, angle, side. Now the last one we're going to look at is a special case. Okay, it's called the hypotenuse leg congruence theorem here. And it's specific because it can only be used with a right triangle. So in this, you can see that there's only two parts, and I've told you that you need a minimum of 3. That third part is the right angle that they gave us here. So you can only do this with a right angle. And it shows at the bottom the hypotenuse is always going to be the side right across from the right angle. Okay? So in this case, our hypotenuse is segment BC, and that's going to be congruent to segment EF. Okay? And then it tells us that a leg can be either side adjacent to the right angle, one of the two sides that creates our right angle. In this case, they told us that AB is congruent to DE. Okay? And if that's true, if you've got a right angle, you've got hypotenuse being congruent, and you've got one of the legs being congruent, you can say that these two triangles are congruent. Triangle ABC is congruent to triangle DEF. But the big key here is that it has to be in a right triangle. So taking a look at our last proof here, the left-hand side is filled out, and in this case they tell us that we have right triangles here. Okay, so that means that I also have a right angle at angle MPN. So that is given. And they also told us that segment ML is congruent to segment MN. So that was given to us. Now, if we look closely, straight across from these right angles will be my hypotenuse. So I'm going to label that with an H, just to keep our minds on that. Okay? And then if you look, they said that MP is congruent to MP, which we know to be a reflexive property. Okay? Now, this would be my leg right there. It's one of the pieces that creates my right angle. So I have my hypotenuse congruent, I have my leg congruent, and I have my right angle. So I can say that this is congruent by hypotenuse leg. Okay, so those are the other 3 congruent statements. There's some extra practice I did not finish on pages 21, 22, and 23 that I encourage you to take a look at as we prepare to finish up our chapter on congruent triangles. Have a great night, everybody.